At the user group meeting this past week, I gave a presentation on containers in Azure. Unfortunately, we ran into a few issues with the recording. So I'm going to be running through the presentation here and post this video on YouTube instead of our usual meeting video. So, to get us started, let's look at what we will be building in this presentation. So the overall application is a UI app that calls a .NET service, and that .NET service is basically going to take those requests, look at the request URL. Depending on that request URL, it's either going to redirect it over to this Node app that provides account service, or it reroutes it over to this thing service that provides just a little CRUD API that talks to a backend database. The account service is written in Node. The thing service is written in Python. This service that does the redirecting is written in .NET, ASP.NET Core. This pattern is commonly called the backend for frontend pattern, and it's a pattern that's growing in popularity as we have multiple different microservices that propagate out against the backend. It's pretty common for a team to adopt this backend for frontend pattern. That is a server that still runs on the server, but it aggregates these different backend services, provides additional logic, so that you don't end up with that logic drifting all the way to the UI app. Our UI app in this example is just a React app, and because we have this backend for frontend service in here, we can see that our UI app doesn't really know or care that the count service comes from this Node server over here, that the Python or that the thing service comes from this Python service over here. It's just calling back to its server that provides all that aggregation against those multiple systems. The BFF service is also going to serve up the static assets for our UI app, so all the HTML and JavaScript and CSS and all that is going to be served by this BFF, by this backend for front-end service. Each one of these backend services will be hosted in a different container. We'll use Docker when we're running locally. So we're going to have a Docker container that hosts the BFF service. We will have a count container that, a Docker container that hosts the count service. We'll have a Docker container that hosts the Python service. And then when we're running locally, we'll also have a database container that hosts this Microsoft SQL database. When we eventually look at pushing it up to Azure, we won't use a container stored in Docker, or we won't use a database stored in Docker. We will be using SQL Azure. But when we're running it locally, we want to be able to quickly work on this system so that we can just start the system up. Because of that, we actually run it in a container when developing locally. All of these containers, when running locally, is going to be orchestrated by a tool called Docker Compose, and we'll look at that a little bit. But that is what we will be building. I'd also like to run over real quick the tools that you'll need in order to run through this example. I do have this example posted up on Docker, and I will share the link to that at the end of the presentation. We also have it posted out on our Slack site already. But the required tools that you'll need is pretty simple. You need WSL2, Windows Services for Linux 2. You'll need the Azure CLI, and you'll need to install Docker Desktop. Now, the install of these has actually gotten quite a bit simpler over the last few years. WSL, Windows Services for Linux, it can now be installed just by hopping out to a PowerShell prompt on your Windows computer. If you have Windows, I believe 10 still works, 10 or 11, and you can just type WSL -- install, and it'll pull down all the bits and set up Windows Services for Linux for you. Used to be several steps that you had to go through. Now they've got it nicely packaged up into one PowerShell command. And then Docker Desktop used to require Hyper-V be installed, and run in that. But now it can actually run in Windows services for Linux. This is also nice. Another nice benefit of this is if you don't have the professional version of Windows and you just have Windows Home, this will still work in Windows Home now. Used to be that in order to run Docker, you would have to have something like Hyper-V or something like that installed. But at this point in time, Microsoft has kind of made sure that these different tools work in all versions of Windows. So this will work in Windows Home Edition. Install these tools right here. I should probably also add I'll be working in Visual Studio Code, but other than that, this is the only tools that you will need in order to complete these examples. The examples that we look at, or the Git repository that we look at, is broken down into a couple of subdirectories. There's a documentation directory that I have a couple of notes on going through it. Most of the notes that we'll be following is this working with ACI, working with Azure Kubernetes instances later on. And I have a few notes in the working with Docker locally. These aren't really published set of instructions. They're more so just kind of my notes as going through it. But I think, maybe watching this video and referring to those notes, someone could probably run through this on their own if they wanted to. We also have an infrastructure folder. This contains our Docker Compose files. We'll look at this in a little bit. And then I have a source folder that includes the source code to those different backend services. And we'll look at those in a little bit too. All right, so let's dig into the three services that we built a little bit. I'm not going to go into too much detail on how these services were built. They kind of were intentionally built as pretty simple services. I chose 3 different languages because I think that's a kind of a strength of Docker, and a system like this is one of the reasons why you might use Docker is if you're needing to build a system that composes of multiple different languages. Maybe you have a machine learning team that is building models and stuff in Python, and so they'd like to use Python to serve those up. And maybe those are being consumed by a .NET team, and so I think the fact that we increasingly have multiple different languages in our solutions is a really good reason to use this Docker system. So that's kind of why I chose three different languages to demonstrate that you can do that. Each one of these services, first I'll just talk about the count service and the thing service a little bit. So count service and thing service both have their own Docker file. Docker file is kind of describing the build process that it's going to go through in order to build these images. It's going to walk through building it. The count service, the node one, isn't all that fancy. And to tell you the truth, the Python one isn't all that fancy either. They both pull down the dependencies. They're using a feature called multi-stage builds. We won't dig into those too much, but multi-stage builds is a way that you can build your application in one image and then copy the output of that build into another image and run off of that. So they are both using those multi-stage builds, and you can actually identify that. I'll show you in the Docker file. You can kind of identify that as we have one stage up here that's starting from this image, and then we're creating another stage down here that's using a different image. And we're in this case we're copying from the first image to the final image, and so that's just kind of how we're working those two systems. I will call out in the thing service here, the Python service, because we are talking to a database, we have to get configuration into the system on how to connect to that database, and we do that through environment variables. That's a very common pattern. It's a very common pattern when working with Docker is to any sorts of configuration that you need, just read from an environment variable. And other parts of your system, we'll look at how Docker Compose does this later on, but other parts of your system will set those environment variables for your application to consume. So, instead of looking for a web config file or something like that, a static file, you're going to look to that host environment and say, give me my settings. That's used in the thing service. The count service, I don't have any settings just because it is so simple. It's just basically storing a static variable and returning and incrementing that static variable, where the Python service, the thing service, is talking to a backend SQL server. On that backend SQL server, so Microsoft does have a SQL Server Docker container available. It runs in Linux and it works out really great. This is just a little Docker file that I have wrapped around it that sets these two environment variables. These two environment variables are required when you're using it. You have to set the password and you have to accept the Microsoft's license agreement. So I basically just have a little Docker file wrapped around there so that I don't have to set these every time that I start it up. I can just start up this Docker file. It's gonna use this Docker file and pass these environment variables in there. That way I don't have to do it every time. All right, so then let's look a little bit at the UI service. So our UI service is structured a little bit differently. All right, so our UI service is structured a little bit differently from the other two. First off, I have a single folder that contains both of these service. Part of the reason is when Docker is set up as a client server process, so a lot of times when you're interacting with the Docker command locally, you're interacting with a client piece that's then talking to a server piece. In most of the cases, that server piece is sitting on our desktops, but there are times when you're going to be connecting to a remote computer and you're running a local Docker command that's connecting to that remote computer. And one of the things that it passes over there is when you tell it to build this, you have to give it a context, and everything in that context is going to be copied over to that remote server. So in the case of this, the Docker file that I have here, I basically want the BFF service and the UI app copied over to that remote Docker server to build it. I don't want anything else copied over. I don't want to have to send the count service over there when I don't need it. I want the count service context to only consist of the count service, the thing service to only consist of the thing service, and the UI context to only consist of the UI. And part of that's when you issue the Docker build command, by default, the location of the Docker file will be the content. So the Docker file is in this UI folder, so this UI folder will be the context. You can pass it separately if you want to, but I do want to make sure that I have my folder structure here set up in a way where I can just pass these two UI pieces here. These two UI pieces, one is an ASP.NET app, and one is a UI, is a React.js application. And those two are built a little bit differently. So we're going to use that multi-stage build to build them out as two separate things. So here in this first stage, we're going to work with the Microsoft .NET SDK. The SDK, Microsoft has a couple of containers for .NET. The SDK container contains everything that you need to build .NET applications. You can also run .NET applications with this, but it also includes everything else that you need to build. While they have another container that is just the runtime, and that only includes the bits that it takes to run it. So I can't, for example, in this ASP.NET runtime one, I can't build a .NET app. I can only run a .NET app. The reason that's important is because this image is a lot smaller. So you end up with a lot more smaller, compact container that you're storing, that you're moving between these systems, and that you're running. So we start off with the first stage with a .NET. We copy our CS proj and restore it. Part of the reason that we do that is this creates a cache point here. So the result of this is going to be cached off. and then we can copy our source code over to that same location. The reason we don't copy our source code at the same time as we copy our CS proj file is we don't want this cache point to be invalidated every time we change code. We just want it to be invalidated every time we change dependency in our CS proj. So that gives us one cache point that's just looking at, here's the dependencies that the project has. Here's another cache point that's changing every time the source code changes. And we get to benefit from this being cached quite often, where this will change a lot. So here we go through, we use this first stage using Microsoft's SDK container. We build our application. We're kind of tagging this stage as the BFF build. And then once that's done, we're going to go to the next stage. And the next stage, we're working with a totally different container. We're working with Node. We're working with a Node container here. In this context, we don't have the bits that we need in order to build a .NET app. We can just build, we can just use Node to build our client-side application. So we're kind of doing the same thing. We're copying the contents of our application over. We're gonna, I guess we kind of do a little bit extra work here just to install this little server program. I guess this is probably something that's legacy. I don't even think this is needed. But we're copying over our package.json file over. We're installing those dependencies again to create that cache point, kind of like we did in the other one. Then we copy over all of our source code and we run build. At this time, we have two stages. We have a UI build and a BFF build. They both built their apps. They are in two separate containers at this point, or in two separate images at this point. So what we need to do now is we need to create our final image, and this is going to be the one that's actually going to serve up that our application is going to run in. What we need to do is start off with that ASP.NET Runtime image, and we're going to copy from the BFF build, from this first stage, we're going to copy the contents of /app to the current directory. And then from the UI build, we're going to copy the contents of home app user build, which is where I happen to run it in the Node side. We're going to copy the contents of that build result to our root. If you know, in ASP.NET, they make it pretty easy to serve static assets out of this root, and it just looks like the root directory of your application. So here's so basically what I have is I have our .NET application. It's running. Those static assets from our React application are now placed in this root, and then we simply we tell it how to start up our web server by issuing the .NET command and pointing to that BFF service that we compiled earlier. All right, so we've looked at kind of the source code layout and the Docker files, those individual Docker files. Just as a reminder, that's the pieces that's building these individual containers. We haven't quite talked yet how they talk to each other, how they work, how they work together. But I'm gonna take a little detour here, and I'm gonna dig a little bit into the code on our ASP.NET application here. Talk a little bit about what it's using. When I was building through this, I found an interesting service, an interesting tool that Microsoft provides that I think is worth calling out a little bit. So the tool is this YARP project. Stands for Yet Another Reverse Proxy. It's a tool, like I say, it's a tool that Microsoft has developed and put out there. It basically gives you the functionality to build reverse proxying capabilities into your .NET application. A lot of systems that I've seen, they will have an entry point, an API entry point that maybe consists of something like an Nginx container that does a lot of this routing to different systems. I think that's a great pattern. The one downside is because it is just an Nginx server, you don't get an opportunity to do additional logic if you should need to. Where this YARP tool allows you to configure this reverse proxy inside a .NET application, which opens up additional capabilities to you. So my .NET application, I have several files in here, but really the only thing that's really doing much is this program. So I'm using the new .NET Minimal API, so you don't see the namespaces or class or anything like that. Still getting used to that. Not sure what I think of it, but it's what I chose to use on it. So we use this YARP reverse proxy. Most of the examples that they have out there configure YARP with JSON files. I think the one limitation to JSON files is in this example, I needed to be able to pull environment variables and adjust my routing based on those environment variables. And unfortunately, you can't do that if you're using JSON configuration files. You need something that you can set up and have a runtime add on them. So this example, I did find in one of the YARP examples. So like this in-memory config came right from one of Microsoft's examples. So it's not my code, but basically in this first part, we're gonna create a route config, and that we're gonna create a function that returns our route config. And a route config is just everything that we're listening to coming in. So what we're saying is, when a request comes into the system, look at it. If the path matches, count / anything afterwards, we're going to pass it to the cluster server or to the count server. If a request comes in thing, thing with anything after it, we're going to pass it to the thing server. And then we have this get clusters, and I have a little bit of my debug in there. I'm gonna just to make sure we can read this, I'm gonna clean up my debug there a little bit. So then we have this get clusters, and this is defining those count servers. So up here, when we said pass it to the count server, this defines what that count server is, where that destination is. And so if it matches the count route up here, it's going to get routed to the count server. And the count server is basically just going to redirect it to this particular address, which is count host, count port. This is also where those environment variables come in. Count host and count port are ultimately coming from environment variables that I'm going to set in this system. So I have count host, count port, thing host, thing port, both kind of work in the same way. The other thing, I guess I do configure CORS in here. One of the benefits to this backend for front end pattern is since the web application is calling the same server that served it up, I technically don't have to mess with CORS. It's same origin already. But I go ahead and add Razor pages. I guess I don't really need that in this one because I don't serve up any Razor pages. I add my reverse proxy, pointing to the routes and clusters config functions that we have in there. I add CORS. I tell it to use static files. This is what's going to tell it to look at that www root, which will contain our React application. Tell it to use CORS. Another thing that I do in here is I have a little endpoint in here with settings, and this settings keeping in mind that we want to do as much configuration of this system as possible through environment variables. What this settings endpoint does is it exposes some environment variables. So I have a instrumentation key that this setting is going to return, and it's ultimately pulling from an environment variable looking for something called applications insight key. If it doesn't find it, it just returns test. I tell it to map my proxy. I put a fallback file in there. So by default, .NET will look for an HTML file, but the React build process builds an index.html file. This also, I believe this will also tell it that if I go to any file that doesn't match this, it's automatically going to serve up index.html file, and then we run it. All right. So now we've kind of looked at the source code. We've looked at those individual Docker files. Let's look at the piece that ties all of these together, and then we'll go ahead and run this application locally and see what it looks like. So we're going to use a Docker Compose file. Docker Compose is the piece that we're going to use to tie these separate individual services into one cohesive system. So Docker Compose will refer to each of those individual Docker files. It can kind of handle some of the building of those Docker files. And then we'll also use this to publish those images to our remote container registry in one of the next examples. For each of these, so the Docker file it's a YAML file. So we have a list of services that we're going to be listing in here. And there's other things there's some other things that we could define. We could define volumes and other stuff. Volumes give you mechanisms like if we wanted to share directories between them. If we maybe wanted to share a directory with our host system, we could define it in a volume. We don't use any of that with this particular example, but we can start to drill into these. So like our count service, we're going to create a new service called count. It's going to have this image name, and this image name is eventually what when we publish it to our remote container registry, you'll show it up there. We'll also be able to look at that image name when we're running it locally. So we're going to build that image name. Here's the directions that's passed to Docker in order to build it. We can build each of these containers individually, but using this mechanism, we can build them all at once through this Docker Compose process. And basically all that we're saying is the context for this is if I go back up to the source directory, to the count service, and there's a Docker file in there. So earlier when I was talking about that client server model and it's going to pass the content of the context to there, that's what this is referring to. So everything in this particular folder is going to get passed to the Docker engine along with this Docker file to build the system. And then in ports, basically all that we're telling it is we're going to expose 5001 on my local desktop, and that's going to be pointing to port 8080 inside this count image. I primarily expose the individual ports when running on my local system just so I can debug. So if I wanted to, I could get to it without going through that BFF service. So I expose those individual ports. This doesn't have anything to do with how the individual images talk to each other. This is just the way that me running on my local system can reach into that system, into this system. For our thing, really similar. We give it an image name, tell a little bit about how to build. We export that port 5002 pointing to port 5000 in the container. And then we also tell it depends on the database. The database is pretty simple again, has an image, point it to our Docker file. We don't have a context that we necessarily need to share with it. We have some ports that we expose to our local system. The BFF, we have an image, have an image name. Again, we have the build settings, we expose some ports, we tell it depends on the thing service and count service. And and then we pass some environment variables. So inside the Docker network that's going to be set up, inside that Docker network, the names of them are the names that we have here. So if I'm inside that Docker network and I want to talk to the BFF, I can just refer to it as, HTTP:/BFF, because I named it BFF here. Same way, if BFF needs to talk to thing, it can just talk to it by the name that we've defined down here. And so I pass that on. I don't set, you'll notice I didn't set the things environment variables, in part because I have to change it when I go to production. I could have set them here, but I didn't. I probably should have in this case, I suppose. Okay, so now that we have that up and running, actually running this, and this is one of the nice things about these Docker Compose files. Once you have the Docker Compose file created, you can build your entire system all in one command. Compose -f infrastructure Docker Compose local dev. So right now I've got a clean system, Docker Compose pointing to the location of that Docker Compose file and passing it the up command. We're going to see it. At first, it tried to pull those images, from a remote repository, but they don't exist on the remote repository, so I get an error right away. And it goes right into building those individual images. As it's going through this is going to take a little while, but it's going to pull down those base images. We'll see if we keep a close eye on this. We'll be able to see, like, when it's building the .NET stuff, when it's building the Python stuff, and things like that. Here it looks like it's building one of those Linux containers. I think in the Python image we installed a whole bunch of other dependencies, and I think it's going through that right now. It's probably actually a anti-pattern to actually be building it, pulling in those dependencies in your final image. Probably should have had an intermediary image that we were working with. Let's see. Yeah, here the Azure Container Registry. So this is building one of ours. We're running pip install, so this is again in the Python one still. It's also building these, taking advantage of multi-threading and building these at the same time. That's why it's kind of hard to follow the output of this sometimes. And it looks like it's done building them, and it is now starting up the system. So at this point, I have a little Docker plugin in Azure that's kind of a nice, handy little tool to use. So we can see that we now have those individual images. So Docker has images and containers. Images are kind of the non-running snapshots of the things that you can run. Each image, you can have multiple containers running for it. Containers are the actual running instance of an image. So I have this BFF service image that's not running. On it, I can have one or more BFF service container running. And in this case, we can actually see that because this was all in a single Docker Compose file, it's wrapped up nicely, shows as one thing. I believe we should be able to run this all. And this is the application. It's running at port localhost 5000 because that's where I had pointed this that BFF service initially. We can see the count service. It's incrementing, so it's routing it all the way to that node backend. The thing service, if I put a thing in there, We can save that thing. We can see the list of things. So that's routing to that Python server, which is in turn talking to the database and getting the full round trip. All right, so now that we've looked at running this locally, let's start to talk about what it's going to take to push this up to Azure. Now, there are a lot of resources. Azure currently has a lot of tools and capabilities to run containers up in the cloud. A lot of different things to choose from. We're not going to look at all of them. We're going to zero in on a couple of these. Specifically, we're going to look at Azure Container Instances, and we're going to look at Azure Container Registry. Azure Container Registry is kind of a foundational piece. You'll probably use something like Azure Container Registry with all of these other options. Azure Container Registry is just the place where you can push those images so that they can be deployed to other systems. If you're familiar with NuGet and how you can push a package up to a NuGet server that you can pull down to other source source repositories, Azure Container Registry is real similar to that. It's just the place where you can push those built images to so that they can be pulled down and consumed when running. So we're going to look at Azure Container Registry, building and pushing our stuff up to there. We're going to look at Azure Container Instances is where we're actually going to be running it. Some of these, and I believe right now Azure Container Instances is probably a good middle ground. Azure Kubernetes Service, yeah, I think your complexity goes up a decent amount there, although it's not as bad as running your own Kubernetes service, or not as difficult as your own Kubernetes service, but it is a little bit more difficult service. Azure Service Fabric, I don't know that this has a very long future. Microsoft tends to be moving away from the Azure Service Fabric, operating using more industry standard container orchestrations as opposed to their version of a container orchestrator. Azure Container Apps certainly looks interesting, and I think this could be the one that in the future I might be deploying my personal stuff to, but it's in preview right now, and so until it comes out of that preview, I kind of hesitant to dig into it too much. Who knows? Maybe we have build coming up in a month. Maybe we'll see Azure Container Apps coming out of preview in that time. There's also another one that's not listed on here. You also have app services that can host containers, and they have, depending on what your need for containers are, you can actually do quite a bit with just app services. But in this one, like I say, we're going to look at Azure Container Registry and Azure Container Instances. So to push our application up to Azure Container Instances, first we have to push our images up to the Azure Container Registry. So to go through this, I'm actually going to be following my notes a little bit closer because there's a series of install steps that we have to, or a series of commands that we have to enter to make sure I get them right. I'm just going to be following my notes up here. So the first thing that we're going to do is we have to log in to our Azure command line. I have a separate tenant that I need to specify. Depending on how your Azure is set up, you might just be able to issue this Azure login on a separate window that I don't have showing on here. This has triggered a Windows login prompt, a web-based login prompt, and as soon as I hit that login, it's going to redirect me back to here and show me that I am indeed logged into my tenant. I then need to log in Docker, and this command is kind of interesting right here. We're typing Docker login Azure. Microsoft has actually contributed code back to Docker and kind of put this little helper function of being able to connect Docker to our Azure instance made it really easy. So we have Docker login Azure. Later on, we'll see that there's actually a Docker Azure Container Instances integration. So they kind of made that easy to work with there. So if we didn't have this, we'd have to be digging in and messing with a bunch of config files on the back end to point it to our Azure stuff. When I hit that, I'm going to get a similar login prompt where it opens up in the separate window. I hit OK, we get login succeeded. The next step that we do, we're going to go ahead and we're going to create a resource group. You could do this through the portal, but we're going to go ahead and continue on with the command line approach. Azure group create, we're going to give it a name of app dev sandbox. We're going to tell it to put that resource group in South Central US. And that command doesn't take too terribly long. Up next, we're going to create our Azure Container Registry. Call it in the Azure CLI Container Registry, create, point it to the resource group that we just created, give it a name, app dev sandbox ACR, and tell it the SKU. There's a premium. For our use cases, we just need basic. That's going to go through, create that. That will take a little bit more time to run. And as that's, okay, so that's created. Let's hop over. I'm going to hop over to my Azure portal here real quick. We can see the resource group that we just created. And in there, we should see okay, it took a little bit of time, but our container registry that we created has also now shown up. I'm going to skip over this step to adding the admin account. One of the processes that I was working on earlier in this presentation that I didn't end up using required this, but we don't need it. We don't need it for what I ultimately landed on. So the next thing that we're going to do, earlier when I was talking about that Docker client server model, this Docker context is the suite of commands that we can use to work with whether I want to work locally or remote. Docker context, I believe it's list. So here's listing the different contexts that I have. I have a default context. I have my I have a Kubernetes one. So I have the different contexts. I'm still pointing to some old Azure container instances. These won't be valid anymore since I've recreated it. But I can really easily redo that with this next one. So this AZ ACR login, all that's telling is going to do is this is going to go out and log into that container registry that we just created, and tell and basically set up the configuration file so that Docker can communicate and work with that. A few other things. Okay, so we've already built our images, and at this point, at this point, we can also push those images. And so now what we're doing is we're taking those images that we had previously built and we're pushing it up to the server, up to that container registry instance. All right. So, so that took a little bit of time, 287 seconds. if I go out to the Azure portal, I can actually see in that container registry, I can click down here on the repositories link, and I will see those individual images that we've pushed up there. So I have a BFF service, account service, a SQL service. I didn't actually need to add the SQL Server service to there, and a thing service. And our next step, so those are setting up in the registry. Our next step is we need to connect Docker to the Azure container instances. And we start that command by issuing this Docker context create ACI app dev context. And this is another command that Microsoft's contributed code back there to create this, to make it aware of what this ACI is. It already tells me it exists. If we remember, I ran that context command earlier. I think it was already pointed to there. I can list our contexts again. See those different ones. I'm currently using default. We will need to switch that, and we can do that just by saying app Docker context use app dev context. Now if I go list those contexts again, we'll see that the star is next to this app dev context. And at this point, the command that I'll issue is pretty simple. It's just this docker compose -f infrastructure local dev. I'm going to change this instead of doing local dev, because if you remember, our local dev instance included our SQL server. I'm going to issue this docker compose -cloud. I'm going to use this -cloud one instead of local dev. This -cloud one, it's a little simpler, more simple. It doesn't have the build in there because it doesn't need to know how to build the images. It's just going to pull the images from the registry. It also doesn't have the SQL server in there because ultimately we'd be using Azure SQL Server instead of our own SQL Server. So I'm just going to docker compose -f infrastructure, point it to that cloud one, and then issue the up command. This is real similar to how I'd run it locally, but since I am now pointing my Docker command to the Azure container instances context, it's going to use that. And I don't go dash up, you just go up. All right, so with that command, it's now going to be going out and creating those. Should create them pretty quick. And we can see, if we go back to our Azure portal, we're in that app dev sandbox resource group. We should see popping up here in a little bit. This shouldn't take too terribly long. Shouldn't take too long because it's just pulling those images that are already up in our remote registry. So I see if I refresh it, we now have that container instances that's been created here. It's named infrastructure because that's what's in that's the folder that I'm working out of. And we're still not started yet, so we're still creating those. All right, so at this point, those individual services should be created. Should be able to come out here, refresh this now, and we'll see we now get an IP address. If I copy that IP address and hit that endpoint, we should see it start up and serve up our application. Hopefully. Hopefully. running. Let's look at our containers. Our BFF is running. We'll notice our thing one here has so let me back up. This is a list of those individual containers that we're now running in there. The thing service is having problems, and that's kind of to be expected. It's looking for that SQL server, but the SQL server isn't there, and I haven't created one in Azure yet, so this is kind of going to I don't have very good error handling in that Python application, so it's going to crash out. But we should be able to hit our BFF service. I'm not sure why. Oh, okay. There, it just took a little while to start up. So on that IP address where we created those services, it's now running. I can hit the count service. The thing service isn't going to work because that Python server isn't working. But count service is working, so it's at least routing to there. In this dashboard where I have those individual services running, I can look at some log information, some properties on it, look at any events. Now I don't have very good logs around this thing service, so I'm not going to get a lot of logs running in here. But if I look at some of the other ones, like here's the BFF service, I can see quite a bit of logs. Every time it's proxying to one of those backend servers, I can actually see it logging that message because I told it to log. Let's see. Another thing that's worth calling out is I don't get this doesn't have all the functionality of some of the options in Azure. I don't get an SSL certificate out of the box, so I have to do some additional work if I want to run this under SSL. I don't get nice DNS. I have to do a little bit of work if I want DNS running in this. So a little bit of additional work, but at this point, I've now built those containers out locally, pushed them up to Azure Container Registry, and then started up some Azure Container instances using those images and serving my site successfully. So with that, that's the end of the presentation. All right, thanks for joining me.